Thank you for joining us today for supporting Stormwater with ArcGIS. In today's webinar, you will learn how Esri can help with the collection of assets to support management of your stormwater system. Presenters will discuss best practices and ArcGIS configurations that will help you map your system. Joining me today is Mike Miller, Howard Crothers, and our special guest, Nicole Beck. Nicole Beck is the CEO of Second Nature and has a PhD in aquatic chemistry. She has dedicated her career to figuring out how to bring science to decision makers. With over 15 years in stormwater consulting, Second Nature has landed on providing scalable geospatial software solutions to simplify regulatory compliance and accelerate effective stormwater programs.
Mike, I think, did a great job of showing the value of the site scale asset management and mapping that's critical to the foundation of any MS4 program. So I'm going to start with the challenges just real quickly. You know, nearly every city and county and university across the country has an MS4 NPDES permit. And nearly all of those have what we'll call minimum control measures or requirements. And we've seen kind of a universal siloed approach, if you will, to complying with these minimum control measures, such that, you know, program requirements can be spread across multiple departments, and thus the demonstration of compliance becomes reliant upon several people across these agencies. Programs typically also lack an information management system that integrates all the elements of their compliance program. So the result of these kind of silos of data is that when you go to do your annual reporting to the associated regulatory authority, it becomes time-consuming and costly, and it can take months to compile all the required information from all the different individuals that are involved. And so the results become this pile of paper that contains tables and checklists and narratives and static maps. And in the end, we're finding that these annual reports are taking programs and permittees a lot of time to compile, but it really isn't helping you or your team make decisions. So for any MS4s also that permitted areas drain to an impaired water body, PMDLs are putting pressure on these stormwater programs to be more effective. And when I say that, I mean that these programs are having to demonstrate their ability to reduce the impacts of the urban landscape on their impaired waterways that they're draining to. And that's a heavy lift for MS4s and typically translates, at least traditionally, into a lot of monitoring and modeling expenditures. And so we want to take this approach, really understanding that the benefits of sustainable management of rain that falls on the urban landscape expands well beyond just improving water quality and reducing pollutants to these local waterways, but also that capture and reuse, green infrastructure, low impact development, they all provide multiple benefits to communities that span beyond just the environmental benefits and reducing flooding and improving water quality, but also expand to the social and economic sectors. And that's, you know, Second Nature as identified an opportunity, and we've created a software platform called 2Nform to specifically address these challenges. So it's a cloud-based geospatial framework, and it eliminates these stormwater program data silos. We allow you to leverage your existing GIS investment and integrate with your existing data management systems through REST APIs and integration with ArcGIS online groups. So the modules on the right align and look similar to the minimum control measures that are in permits across the country. Actions, projects, and asset information is managed spatially, and it aligns with the Esri utility network data and the stormwater network data model that Mike was showing. And we'll talk about the structural BMPs, but all of that typology is consistent, and we worked with Esri to make sure that was so. But we extend the Esri network by providing users more efficient, precise, and repeatable assessment and inspection methods. The tool serves as a compliance calendar to help you and your team better manage your workflows, which would include when inspections are due, based on the results of those inspections, where maintenance is required, and also helping manage enforcement actions and the information associated with that. We then provide a series of advanced analytics to provide permittee staff with actionable information that empowers them to understand the cause and effect linkage between the urban landscape and those regulated waterways to which they're draining, and manage, in essence, stormwater more as a resource and less as a waste product. So really, we're aiming with this product 2Nform to make people who manage stormwater more efficient and their actions more effective at cleaning water. And with limited time, I'm just going to go into the structural BMP module here and give you a little bit more detail. So imagine this is one of those, like the wet basin that Mike had shown. You can record these assets either in 2Nform or using the Stormwater Utility Network, and we can digest that data. And like I said, the typologies are consistent. We've spent over a decade now refining those types such that you can define any structural BMP, which is an engineered structure that is designed to accept stormwater and reduce the volumes and pollutants going to it, by one of 16 types. Two people looking at the same BMP are going to call it the same thing. And then their key specification inputs, as Mike was showing on the screen, depending upon the type, like footprint and drainage area, et cetera. And we use that specification information as well as the relevant design standards to calculate the BMP's expected water quality benefit when it was installed. We then provide our users a rapid assessment protocol series that are both objective and precise measures that output the current performance of each specific BMP. Oops, sorry, wrong direction. And those are all in mobile applications, both on Esri products as well as our responsive app. So we could train anyone to perform these assessments in a day, and it takes minutes per BMP to complete. And the performance then is mapped and distributed. So this is a collection of the structural BMPs within the city of Salinas, and the red BMPs now have a high maintenance urgency. All of the information that we're capturing in this module addresses a number of MS4 permit requirements. So I can go into an automated to-do list here that is helping users conduct timely assessments and inspections and really help you manage your workflows. So what I'm showing here is the identification of where the maintenance actions are needed on these structural BMPs within that population. And that allows the Stormwater Program Manager to focus efforts and understand the resources needed to restore specific stormwater BMPs back to their intended design. Right? If these things work and accept water, they eventually lose capacity, grow vegetation, et cetera. So they do need to be maintained. And once they're maintained, the assessments are repeated, the restored performance of the structural BMP is documented, and you can just think of this entire module as a green infrastructure asset management system. Oh, keep hitting the wrong button. Okay, so if you do any looking into second nature, you'll learn that we're science geeks. And so what we did is developed and coded an urban hydrology and pollutant loading model into 2Nform. And we leverage available spatial data and land use data sets. And the first place that we start is a baseline load, the total aggregated pollutant load from the city to the local waterways, without any BMPs included. So in this example, it's just under 550 tons per year. And the map is showing the 68 urban catchments that make up the city of Salinas. So building upon the site scale catchment delineation that Mike was demonstrating in the utility, we expand that and do that for the entire MS4 area. And we provide guidance so that anybody with any GIS expertise can follow this and create this network. And this becomes the geospatial framework that's underlying 2Nform. In this map, the catchments are colored to show the relative distribution of pollutant loading around the city. The dark brown drainages now are where the greatest water quality improvement opportunities are. And this map then becomes really a valuable strategic planning communication for the city, such that they can identify and communicate where their opportunities and improvement priorities are and why. And so now if we think of all those green infrastructure assets that we were just looking at, they all exist within different urban drainages. And these assets, coupled with effectiveness assessments of other select source control and ground control efforts, are used to quantify and track the load reduction project progress achieved as a result of collective program actions. So the idea then is over time, as more effective actions are implemented to reduce stormwater volumes and pollutants, water quality progress is achieved. And the city now can report that progress using both the changing map, identifying where this progress has been made, as well as the load reduction accounting. So you can think of the reporting elements as a stormwater accounting system that is both scalable and testable and technically defensible. So typically pollutant load reduction models are costly and they're complex, but now stormwater managers can have such models at their fingertips, and you can run heuristic scenarios and better understand how to plan and implement a more effective program. And we think this accounting system is going to come in really handy as the EPA and state regulatory agencies ramp up support for water-based markets and require stormwater programs to go to a performance-based program. Such an accounting system also can help you obtain stormwater funding and really answer that question that I posed at the beginning: how effective is your stormwater program at improving water quality? So lastly, just to touch back on the other point of making digital reporting more efficient. Each year when your annual report is due, the permittee administrator reviews and locks their records for the various modules, both program management as well as program effectiveness. And once those are locked, there's a notification to the respective regulator that their annual submission is ready for review. And so then a regulatory portal is available, and that significantly reduces your effort and time and cost to prepare and submit your annual report. So with that, thank you for your time, and check out our website at secondnaturewater.com, and please contact us if you'd like to learn more.
Following up on that question, is there a capability to do hydrologic or hydraulic modeling?
That's still a capability. We look to our business partners to sit on top of the utility network to take those features and perform that analysis.
And so if I could add, Krista, that I showed the pollutant loading, but also it models urban hydrology. And we have published the modeling approach. So it's comparable to SWIM and HSPF, other typical urban hydrology models. It's called the Tool to Estimate Load Reductions, and I'm happy to provide the publication on how that is done. But that's available within the 2Nform platform.
Thanks, Nicole. Thanks, Mike, Howard, and Nicole. Great webinar. Thank you, everyone, for joining us. I hope to see you again on one of our future webinars. Have a great day.
Thanks, everyone.